Hello, I'm going to solve two simple machine problems today. The first one is going to be a pulley system. This is a simple pulley. Now how do we know that? Well, it is fastened here and there's one continuous loop of these strands until we get down here where you're pulling on it. That's a simple pulley. If we have a simple pulley, we're allowed to use the magic trick of cutting across all the lines and counting them. 1, 2, 3, 4, 5, 6, 7. However, can we count this line right here? No, because this direction where we're pulling is down. Gravity is pulling us down. If the directions are the same, we can't count the line that we're pulling on, so it is only 1, 2, 3, 4, 5, 6. So the mechanical advantage is, or the ideal mechanical advantage is 6. That's a magic trick that you need to know how to use, and it only works on simple pulleys. Okay. The problem we're going to work with is no friction. We're asked to find the effort here that you're trying to lift the 1,200 pounds. So, as always, let's list our knowns and unknowns. What do we know? We know that the ideal mechanical advantage is 6. We know that FR is 1,200 pounds, and there's no friction. What's our unknowns? Well, FE, that's our F. Okay. So let's go ahead and work the problem. Because there's no friction, we know that IMA equals AMA. The IMA here, we don't have distances, but we use the trick down here to find the IMA. So 6 equals FR over FE. What are we trying to find? FE. Let's go ahead and rearrange the problem. FE equals FR over 6. And the FR was, or is, 1,200 pounds divided by 6. And without my calculator, I can come pretty close to the answer of 200 pounds. Okay. So if you can pull with 200 pounds, you can lift 1,200 pounds, 1,200 pounds with this block and tackle. Okay. All right, let's work another problem. How about let's work a gear problem. All right. So we have a gear here. Okay. Actually a gear train, a simple gear train. How do we know it's a simple gear train? Because these do not share a shaft. So if it got a simple gear train, we only have to worry about the input and the output gears. Okay. Now, I've already counted these. I think if I left it on here long enough, you could count that A has 12 teeth, C has 18 teeth. You can get that from counting. It may not be given to you. You may have to count it from the picture. Okay. So if our input gear A is being turned at 25 RPM, what is the RPMs of the output gear C? Okay. What do we know? We know NA, or the output, or the input, excuse me, is 12 teeth. We know the output, which is C, is 18 teeth. And we know omega N, or omega A, is 25 RPM. Okay. What's our unknown? We do not know our omega out or our omega C. Okay. So let's go ahead and our write down our formula. Our formula is N out over N equals omega N over omega out. And you don't have to have that memorized. Remember, you've got your formula sheet. But here we've got out over N over out. Remember, they're inverse relationships. So what are we trying to find? We're trying to find omega out or omega C. Let's solve for that. So omega out is N times omega N divided by N out. And what do we have here when we plug in the numbers? Omega N, the input or A, is 12 teeth times 25 RPMs divided by the output or the C, which is 18 teeth. Working that out, we end up with something close to 16.7 RPMs. Okay. So that is the problem with the gear. Okay. Thank you.